Welcome back. We're on question 10. So let's take a look. The map below shows part of a town. It does. Good. Now there's nothing there that's mathematical really, so let's not underline anything. Distances are measured in kilometers horizontally and vertically from the train station and shown in coordinate form. Okay, in other words, there's a scale here. These are kilometers, 10 kilometers across the town and 11 kilometers up and down the town. First Street and Second Street run from east to west, east on the left, west on the right. Write down the equations of First Street and Second Street. Okay, so on First Street, the y value is always 1. The x value is variable, but the y value is fixed at 1. So First Street has an equation y equals 1. Okay, and Second Street has an equation y equals 2. Let's call that First Street and Second Street. But I'm quite sure any good marking scheme will allow you just write y equals 1 and y equals 2. Fifth Avenue runs from north to south, Write down the equation of Fifth Avenue. Now in Fifth Avenue we say that the y value is variable, but the x value is invariant. It's fixed, it's constant. X value is always 5. So here we're going x equals 5 is the answer. That equation is the same as Fifth Avenue. Notice as well they call it Fifth Avenue and 5, so that was a nice little thing here. Now I see the transverse road has different points on it. Let's just note before we turn the page that the intercept is 6 and that the slope, because we're almost certain to have to find it, so we might as well go ahead and find it, there's a rise of 4, or a fall of 4 actually, so I call it negative 4, and a run of not quite 3, so I'm not going to use t because t is not called a lattice point. It's not much good to us. Lattice points or grid points are way better. U is neither a grid point, but V is. So I'm not going to use that minus 4 actually. I'm going to use the fact that minus 6 and 4 are very good for us. So the slope is minus 6 over 4, which is minus 3 over 2. That's telling me is there is a lattice point here as well, so I could have used it, but then again it wasn't mentioned, so that's what the 3 and the 2 are telling me. Okay, so we have slope negative 3 over 2 and we have intercept 6. So knowing that will make things much quicker as I flick the page. Now it's not ideal in this situation and it doesn't tend to have, the state exams would probably try not to do this to you. Okay, anyway, transverse road. And actually they did, do you see the way they did actually make things a bit easier for us by pointing out that. Find its equation. So it's intercept, so we're using y equals mx plus c. Let me see, do I have a log tables handy? No, here. Okay, this is not a great lesson because I'm always telling you how important it is to have your equipment. Oh, I do have a log tables here. How to have your equipment on the desk ready for use. That's called being tactical. Strategy is a word we use for the maths itself, but tactical is above maths. Okay, I'm going to coordinate geometry, page 18. And we see that the equation of a line is written in 2 forms. It's written, it doesn't name it, but so you need to learn off that this is the slope intercept form and this is the slope point form. Okay, so we'll use the slope intercept form y equals mx plus c, which I've written here. Okay, so the m is minus 3 over 2. Y is a variable, minus 3 over 2 is substituted, and 6 is substituted. Find its equation. So that's the equation. State in your own words a theorem on your course which explains why lines, a distance TU, distance from TU to distance UV, why are they equal? Okay, distance, so this is a transverse. So what we have is we've our parallel lines here, the x-axis, first street and second street. So x-axis, first street, let's call it, the x-axis is y equals 0, y equals 1, y equals 2 are parallel lines equal distance. And the theorem, I'll be honest with you, well, I'll give you the words for the theorem, and that is a transversal cutting, and we'll look at exact words from the syllabus in a moment. A transversal cutting equal distance parallel lines creates congruent line segments. Now, I'm not happy making it up in my own words, so let's go to the syllabus. Appendix B, and we just look for it here. If here it is, theorem 11, if three parallel lines cut off equal segments on some transversal line, they will cut off equal segments on any other transversal line. So stop the video, pause this, write it down. This is your theorem 11 that you're learning off. You're learning off all of these verbatim without any deviation. Definitely try to understand them, so if you're stuck you'll be able to explain them in your own words like I've just done. But that's no substitute to doing a little bit of traditional rote learning. As long as it makes sense and you understand it, then these words are choice words, they're excellent words. This is the syllabus. If three parallel lines cut off equal segments on some transversal, by the way, on the some transversal, we're talking about on, say for example, the y-axis, equal and equal, then they're equal on all transversals. So let's do, I'll switch back here and make three parallel lines. I'll actually print this. And I also want to take you through finding this, and I don't want to give you a link on Teams or anything like that. Let's go to curriculum.ie. Just remember that, curriculumonline.ie. Okay, just look up, even if you look up curriculum, school curriculum, just give you an idea of just how easy it is to end up finding that. School curriculum. Okay, curriculum online. You'll find it very quickly. Go to your junior cert. It take a second to load, or has it load, and then scroll down. Hang on, junior cycle. Yeah, click on junior cycle and scroll down till you see maths. Okay, go into your curriculum specification and go into expectations for students. Now the strands are about to be listed, but just before the strands you see this glossary of terms, well worth looking at. Just a quick peek. Oh, they've done, I'll have to go and contact the NCCA about that. Shouldn't have a dead link, it doesn't look good. And then appendix B is a live link and it's here. Okay. So of course I have already bookmarked that for myself. Appendix B, and you should do the same, but I don't want to give you the bookmark because that would be defeating the purpose. Okay. So what I was going to say to myself is that I'm going to print those first few pages, first 4 pages. I don't want to print all, I want to print customized 1 to 4. Okay, and just have this handy on the side. So, in terms of do you need to know the theorem number? No, but would I recommend it? Yes, because how else are you supposed to be systematic in covering all your theorems? What number was it again? if two triangles converge for a triangle. Am I going in the wrong direction? I wonder the angle at the center. I think I might be going in the wrong direction. Theorem what? Theorem 8, Theorem 7, Theorem 6. I think I might be got lost a bit here. Two lines are parallel if and only if. Theorem 6, each exterior. Theorem 7, in a triangle. Theorem 8, two sides. Theorem 9, in a parallelogram. Theorem 10, the diagonals of. 11, wasn't it? 11, where's Theorem 11? Your three parallel lines cut off. Okay, let's write it down. If three parallel lines cut off equal segments on some transversal remember, notice the if and then there'll be a then statement. If three parallel lines cut off equal segments on some transversal, like that's equal to that, then, here comes the then, it's always part of the theorem, then they will cut off equal segments on any other transversal. They will cut off equal segments. Oops, sorry, picture. Equal segments on, and I want to get the wording exactly right, because on any other transversal. And what is any other transversal? It's any other line bar a parallel line, because any other line you draw bar a horizontal line will always go through the lines, because they extend forever. So no matter what angle I go at, that equals that, that equals that. So if three parallel lines cut off equal segments on some transversal, then they will cut off equal segments on any other transversal. Just to flick back to my web page to check, they will cut off on any other transversal. Don't deviate from the formal your wording, because this is your course. Okay, especially those first few pages, you can nearly just learn them off. I'm not worried too much about this quite theoretical stuff down along here. That I think that'll be true anyway. We'll come back to that as we go on towards the exam. Okay, students, as always, I will see you in the next one.